live with the experts here at DDN. My name is Jason Brown. I'm Senior Director of Product and Solutions Marketing at DDN. I am not Jyoti Swaroop, so if you were expecting Jyoti, we had to switch things around at the last minute. Hence, live TV, live webinars, things happen, but I'm filling in today as your MC. I'm joined by two of our leading DDN experts, Mr. James Coomer and Mr. Izhar Sharon. Gentlemen, can you please introduce yourselves?
Yep, I'm James Coomer. So I look after products at DDN. So I look after the roadmaps. I've been here for a long time. My history is actually in HPC, which we'll be talking about. I did a PhD in theoretical physics a long, long time ago, and now I'm at DDN managing the product strategy.
Hi, I'm Izhar Sharon. I run the customer advocacy for AI for DDN. My background is storage, 25 years in storage, started in development at EMC, running development for Symmetrics or VMAX or PowerMax, whatever you want to call it today, still running. After that, I built XIV storage, got acquired by IBM, spent time with IBM scaling storage. And after that, I was the president for Infinia, another enterprise data storage company, built all go-to-market sales and business, and now acquired by Lenovo. Joined DDN to make the AI revolution happen.
Awesome. Well, thank you, gentlemen, for joining us. We appreciate it. I'm sure all the folks viewing live appreciate it as well. So we're here today for an Ask the Expert session on From HPC to AI, what infrastructure leaders need to know. And we're diving into one of the most important infrastructure shifts happening in the industry, which is how organizations are evolving from traditional high-performance computing, which, James, you said you have a long history in, to AI-driven architectures, right? So there's this shift happening, and we're seeing it all over the place, especially here at DDN. So we're going to cover a little bit about what's working in the field. We're going to talk about key strategies for adopting existing systems and how to future-proof your infrastructure for next-gen workloads. But most importantly, this is your opportunity to ask questions and get insights directly from the people who are helping shape the future of AI infrastructure. So please feel free to drop your questions in the Q&A box, which I believe is in your bottom right corner of your screen or right-hand side. And we'll get to as many as we can during the session. But with that, let's start with some recent poll questions we asked the community. So the first poll question we asked, what are your biggest challenges in integrating AI workloads with existing HPC infrastructure? And we got some very interesting responses. So of the four responses that people were able to choose from, the first one, compute resource allocation, got about 13% as one of the challenges. The second one was around data storage and management, which got 43% of the respondents saying this was their biggest challenge. Network performance and latency, about 4%. So not too many people are having problems with their networks, which is good to know. And then the fourth challenge was around skills and team readiness, which is at 39%. So if we stack rank them, data storage and management, number one challenge when it comes to integrated AI workloads with HPC infrastructure at 43%. Number two was skills and team readiness at 39%. Third was compute resource allocation at 13%. Then last but not least, network performance and latency at 4%. So data storage and management was that top answer when it came to your biggest challenge when trying to integrate AI workloads with your HPC infrastructure. So, James, I'd like to get your insight here, because one question I get asked a lot at trade shows and other events is really, what are the key infrastructure differences between HPC and AI workloads, and how should leaders adapt their environments in that case?
Well, as always, it depends. But let's characterize a typical organization running HPC. These have been running in academic research and aerospace and finance for a long, long time, and they're typically characterized by lots of CPUs, right? Intel's or AMD CPUs. And very often you get a huge mishmash of users and applications, particularly in a research environment like a university or something. So you get the whole range, physics, biochemistry, biology, all doing different things thrown at the system. And in terms of storage and data management, it basically creates it kind of averages out in the end. And you get basically a kind of an averaged out sort of background load resembling all these different applications running at the same time. And then AI comes along And quite often it does something the opposite. Like all of a sudden, you're concentrating everything on one workload. For example, you're training a large language model. Every single GPU is doing the same thing. Every single GPU is pulling data into memory, they're pushing checkpoints into storage, and they're all doing a coordinated fashion. And suddenly, in HPC, we might have been using a sort of average workload where everything smooths out over time. And then AI comes along and it's very, very peaky. We've got huge peaks when we get checkpoints, huge peaks with data loads, huge peaks with model loads. And that's been a challenge because those peaks can translate into inefficiencies across the whole infrastructure. And that means wasting resources, wasting people's time, wasting power, wasting cooling, and all of that stuff. So I guess challenge number one has been coping with the different storage patterns and usage and the peakiness of this new wave of AI, particularly with training large language models.
Yeah, it makes a lot of sense. The targeting the workloads and having them be just different but similar can certainly be challenging to have to deal with. Izhar, I'd love to get your input on the poll, right? So, the top two challenges from that poll, that first poll around, the biggest challenges in integrating AI workloads with existing HPC infrastructure were, number one, data storage and management, which feels kind of a technical hurdle. But then the second one was skills and team readiness, which feels like kind of an organizational hurdle. So from your perspective, what can companies do proactively to really address these issues?
Tying to what James mentioned, it's not just about changing performance that you need out of GPUs, direction, workloads. A lot of the data out there is not as structured as HPC workloads have. Data that you need for AI is everywhere in different formats, and you have to prepare the data before you actually run the training. So we talk about HPC workloads, they have the data. It could be from instruments data, it could be streaming data, but it's fairly consistent in the type of the data. With AI, you have data that is videos for internet. It could be text messages, PDF, MRI images. There's a lot of different data that you need to store in a data storage platform, but you also have to normalize it before you actually use it. So that's, from data management perspective, a key aspect is normalizing the data. Also, you have the data coming from different sources, because it's not like you have, okay, I'm going to move all my data into one location and then I'll start analyzing. You can't just move the data all the time. You have to get some context on the data that you want to bring in. So you have to catalog it. You have to know the context for the data. You have to inspect it and only move the relevant data for the training or for analysis. And the third thing is, when we talk about different workloads, once you've done the training, you want to move it into production, you want to do inference, you want to fine tuning. There's a lot of different aspects that you need to take into account when you have the data architecture that you build. And we all put it under like data management, but it's a data architecture that I have to think when you go and embrace AI. In terms of knowledge, there's a huge gap today in the industry, because you have the infrastructure people, a lot of HPC people that know how to build the infrastructure to build the network, to build the storage, to build the computer GPU environment. The gap is you have the data scientists that want to act and implement their data flows. It's two different type of people, one that know the infrastructure, one that know the data aspect and the analytics aspect, and you have to bridge the gap. What we see customers doing is they actually bring people in that know both sides of the equation, and they bridge the gap in terms of knowledge. But the way we see customers actually accomplishing it, they put teams or pods of implementation, because you can't just have one doing one and the other is doing the other without talking or synthesizing the workload that needs to be accomplished. So have some people that know both the data scientists and the infrastructure and build pods together. And then, you start in small project, Don't try to boil the ocean. Let's have one small AI workflow to start with, and then before you scale. I can go into technology. You need a scalable technology, and I will just pitch in the DDN, because we came from the world of high performance compute. Scaling is in our DNA.
Yeah, absolutely. You can't have one without the other. That's for sure. James, just to piggyback on what Izhar was talking about, what have you seen out there? You said that you've been involved with HPC for a long time and the shift to AI. What are you seeing that customers or organizations doing that can help them in this journey? Izhar mentioned, obviously, the people side of it and the technology side, whether from the data platform. Any insight you have there on that?
Yeah, no, it's really fun for me with a background in physics and HPC. Because what's happening is, this isn't the question you asked, by the way, but it's a precursor to the question you asked, which was, all these physics models are out there, biology models, etc. And what's happening right now is a wave where foundational AI models are being fine-tuned with respect to the particular physics problem, or biology problem, or chemistry problem associated with these traditional HPC applications. So we're ending up with basically both AI and HPC converging on the same infrastructure, because rather than spend a week relaxing a molecule with fine-grained molecular dynamics, we can ask the AI, we can train the AI and then ask the AI to do it in 10 minutes or an hour and really push these results faster. So these surrogate models, these surrogate AI models are being trained based on HPC. And of course, this happens everywhere. So it's happening right now. We see pieces in weather, pieces in particular HPC physics kernels of particular problems being adopted by AI, because it's basically an easy route in for AI. But we'll see it expand and expand and expand. So however difficult you think the problem is today, it's going to get worse as these AI surrogate models start to basically compete or interact with traditional HPC applications on the same infrastructure. So what about that infrastructure? I mean, obviously, we've seen NVIDIA do an amazing job in bringing GPUs to the world, this amazing kind of processing architecture that's optimized for the kind of linear algebra associated with neural networks and training LLMs. And so we need to bring them in to the compute infrastructure, as many data centers have done now. But then, because these are quite expensive things and they're relatively scarce, right? So getting your hands on enough GPUs has been a challenge. And so you need to make sure that all the other rather lower cost elements don't hold you up. So there's no point in finding those GPUs, putting in a data center if the network's holding up, or if the data's holding up, or something else is creating a massive bottleneck. So it's the difference really is, because of the scarcity and the expense of large GPU infrastructure, it makes a lot of sense to spend that extra time considering the pros and cons of various network approaches and various storage approaches, because they're going to make a bigger impact given the costs of these GPUs and the potential productivity of these GPUs, the potential radical changes they can bring about. And as I said, back to what I said at the start, the things to watch out for is this peaky behavior. It's a bit like grand challenge problems. You're running a grand challenge problem when you're training a large language model, and it's essentially thrashing the GPUs, then thrashing the storage, then thrashing the network. And it's not this sort of nice, smooth workload. It's very peaky. And if you don't satisfy those peaks, you're going to be slowing everything down and wasting money and essentially throwing money out the window. Your data scientists are going to be less productive, et cetera, et cetera. So in the end, it means proper balancing of the infrastructure from application to GPU to network interface and DGX, HGX platform, through to network, to switch architecture, through to storage. We can help with that, by the way. So we build an architecture that stretches right across the network into the compute. It's a parallel approach that really encompasses the whole infrastructure. It's not just a storage thing at the end of a wire. We're software that encroaches itself across the whole system. But putting proper consideration into that balanced architecture, which includes GPUs, is more important than it used to be. I'd say that.
Yeah, and that's a great lead into the second poll that we asked, actually, because the second question we asked in the poll was, what's your top AI infrastructure priority? And the number one priority, which goes right back to what you just talked about, James, is keeping GPUs fully utilized. And certainly that can be a challenge, right? Depending on the workload, whether, like you said, it's a bursty, peaky workload like AI or a more consistent one like HPC, you really need to plan for both of those. And it sounds, based on the poll, that is top of mind for the respondents, for sure. Coming in second was improving data accessibility. Data lives everywhere. Data is multimodal. It's structured, it's unstructured, semi-structured. And in the world of AI, what I've learned, I've been at DDN for about a year now, is that people want to be able to use all that data to implement with their AI, workloads and strategies, because one piece of data you might have thought wasn't important at all could become very important as part of this whole bringing the data together. So being able to get that data from different places is certainly important. And that actually aligns with the third priority, which was hybrid and on-prem environments. So like I said, the data lives in the cloud, it lives on premises, it lives at the edge, it lives in a private cloud. Data really is everywhere. And so being able to bring that together in a cohesive manner sounds very important and is a top priority for folks. And believe it or not, the last answer for what's your top AI infrastructure priority, reducing operational overhead, 0% of respondents mentioned that, which is interesting. And I probably want to get your thoughts on that, because it feels like there certainly is some overhead. I don't think people have optimized their AI workload, especially if they're coming from HPC. So I'm surprised that one is at 0%. But, Izhar, these priorities, they highlight the pressure to maximize performance while balancing complexity. How are you seeing organizations?
So, you mentioned GPU utilization. So what that translates to me is they want faster results. Essentially, they want to get, develop a model faster or do the inference faster. But more than that, it means an idle GPU, you're wasting money. GPU is the most expensive part in the infrastructure. When it's idle, you're losing money. So you got to get an environment that has really high performance, high throughput to satisfy the GPU. So you got to build a pipeline that, either multi-tenancy, so you have multiple users for the GPU, or prepare or cache the data before you put it into the GPU. So you got to think about it when you build the environment. Also, we had a customer, we talk about GPU utilization, that wanted to implement a small AI environment with I think it was a few H100s from Infinia, but they're out of power. One of the things that those GPUs, they bring you a lot of performance, but they require a lot of power, and they don't have the data center. So when you think about it, we present that DDN improves the GPU utilization from the 60s to the 70s to the 95% and above. So that's like a 25 to 30% increase in GPU utilization using DDN. That's, of course, it's you get performance and you get results faster, but also you need less GPUs to do the same work. And that customer would not have been able to implement AI without DDN. So when you talk about performance, it's not necessarily about getting things faster. It's actually being able to actually use AI in your data center. It's a key point to make. In terms of, you mentioned data management and hybrid and such. So when we speak with enterprises, their data is not in one location. Different business units have the data in their business unit. It could be multiple locations. A lot of push was done 5 years ago to move to the cloud. So data is in hybrid cloud. It's on-prem and in the cloud. And you can't just move all, I mentioned earlier, of all the data into one location, then, okay, I'm going to build a model right now. Because one thing we know is change is constant. And you always have the data changing. Let's assume it's a huge amount of data. I can't really bring it all to one location to begin with. There's data gravity. So I have to have a technology that can interrogate the data remotely, know when it changed, know what it is, the context, and build an infrastructure that relies on metadata rather than the data. The context, what lives where, when was it updated, is really important, because I need to know if I need the data to do the next run, or to have is it related to what I'm trying to do, essentially. We work with customers that use on-prem and GCP. We work with customers that use on-prem and AWS, but you need a data virtualization platform with strong metadata in order to know what lives where, so you can act upon it. That's, essentially the high utilization GPU is important, not just for performance, but also to be able to do it, to do AI in a cost-effective way. Because at the end, they're running a business. If there's no logic to see the return on investment with smaller number of GPUs, you may not do the project. And the data management part is key, because enterprises, it takes time to do a project, but you want, once you've done the project, to have the data continuously streamed to you, essentially.
Yeah, agreed. And it's when we're talking to folks in the AI space, it's less about speeds and feeds and more about business outcomes, right? It's, how do I maximize my investment? How do I get the best ROI? How do I beat my competition, right? How do I utilize AI to get ahead, right? To increase efficiency, all these things, right? And so, yes, there's technical parts of it, but in the end, it's really about understanding the customer's desires and needs, right? And challenges as well, to be able to get them to a positive outcome. James, I'd love to hear your thoughts on this as well, especially on that, data accessibility piece. Izhar talked about a little bit, but because data is living anywhere, how do you make it accessible? I heard about metadata and utilizing that, but how can we get that data closer to the GPU so that the data storage is not really the bottleneck as part of this whole process?
For those HPC people who are listening, it's not as if the problem is entirely new, but it's just, again, it's on steroids. So old school HPC, research data management, of course, we have data created elsewhere, satellites, microscopes, vehicles, cameras, etc. And we also want to label that data and track it through its lifetime, so we can basically share it with other research groups or adhere to our requirements of our funding bodies, whatever it might be. But now the problem is just 10,000, 100,000 times worse, because every single piece of data, every video file, every frame of video file must be or will be labeled. And from the CIO's perspective, they need to track effectively all these labels, all these tags for every single piece of data, every single model that's been trained or partially trained for the lifetime of the organization. That's where their due diligence comes down to. So if you're responsible for a vehicle driving on a street, if you're responsible for an insurance quote and defending your decision-making criteria, you need to have proper data governance and model governance. And that comes back to handling the data, understanding where the data is and exactly what's the nature of the data, querying the data, analyzing the data, regardless of its location, regardless of its type. Huge problem, right? Because nowadays, as the question that came in was, we've got siloed data, and it's siloed in different ways. It's not necessarily siloed because it's in a different box. It's often siloed because it's owned by a different organization, or it's a different format, or it's in the cloud rather than on-prem. It can be siloed in many, many ways. So what we need is a new data infrastructure that allows you to essentially create a virtual data plane across all your data sources and all your data sinks, all your on-prem or cloud systems, all your edge data generators, and allows you to query and manage that data regardless of its location. So in fact, it's the same problem we saw before. It's just much, much harder now. The volumes have gone huge. The variety of the data is much, much greater. So I'd say, and I think this is a common problem for organizations who are moving heavily into AI, is how do I keep track of this data? Because the number of metadata points associated with every object, every file, it can be hundreds, it could be thousands, and we have millions of files. So all of a sudden, the problem space has changed from being pretty much objects and unstructured data to massive amounts of structured data and unstructured data all at the same time. And none at the same place, which creates a huge challenge. And so, we've been building a solution to this for the past 7 years that allows you to use ordinary tools from today, but if you run it on top of our platform, then you essentially get visibility into your data, and you can govern your data, audit your data, regardless of its location and regardless of its format.
Yeah, and you mentioned a good point, right? At least when I first came to DDN, we focused a lot about in the stack, right? The infrastructure itself, using that to optimize HPC and AI workloads. But now we also see above the stack, right? The applications that are accessing that data or using that data or need that data. There's been a focus there, making sure we can integrate with things like Nvidia AI Enterprise and data acceleration libraries and tools, things like TensorFlow, Apache, Trino, Spark, all these things, right? Because there are companies out there that are developing software to help with this. And so therefore, if you can get that data from one of those applications closer to your GPUs through this data platform, that just accelerates things and once again gets you to your business outcomes faster. We did get a question we got a few questions in the chat, but one question that just popped up, which I thought was very interesting. And I was going to actually ask a question about this because I hear this a lot when I'm talking to customers at trade shows and things. They say, I know I need AI. I know I have data, but I don't know where to get started or what to do. And the question that came in from Mike was, the Fortune 500 clients that I've called on are still struggling with their AI journey. Exactly what I kind of just mentioned. Data is all over the place. Data is not clean. And before I can even propose hardware or any data intelligence platform, how do I introduce the correct resources really to start these clients on their journey? A lot of desire to get into AI, but a lot of confusion about how to even get started. So any tips there? Izhar, I'll go to you first.
So I we hear that a lot as well, and you can do it yourself. Usually you need a consultant. You need either a GSI like Accenture. It depends on the size of customers. You may already have engagement with such large Accenture, Deloitte, and all the such. There's a lot of partners that do that consulting work, but essentially it is a problem. Where do I start? You start in a small project. You start with something that you can contain, because your CEO, which probably has a mandate to do AI in the company, like every other company has, similar to the mandate that cloud, you have to embrace a cloud strategy like 10 years ago. But the difference is, if you didn't embrace cloud strategy, okay, so then your margin will be 20% lower or 20% higher. If you don't embrace AI as a company, I don't think you're gonna be in business in a couple of years. So the pace of AI is moving so fast that you have to do it. So where do you start? You start in an area that is relatively easy to start with, that you do have, the question was, how do you start with clean data? That you do know what the data is, that it's relatively clean, because you have to show your business that your AI journey that you just started is successful. If you just buy hardware and just throw everything at it, you're not going to be successful. You need small wins before you can embrace it, in your data center as a whole, or in the company as a whole. Because I will tell you, AI is it's not scary, but some people think it's going to take their job, and that's the wrong approach. It's going to help you. We use AI in DDN greatly, and it really streamlines what we do. Now, if you have data that is not clean, that's what AI is for. It can, learn, as opposed to just having a neural network. It can actually learn and help you to know where data is, a better. It's all statistical information at the end, but where data is better curated versus low curation or low grade. And AI is gonna help you find that path. You just need to start somewhere. Small project that you think will be successful. Get a team together from the business, the data scientists, and of course the infrastructure, and just do a pilot. That's where I would start.
Yeah, one little hint from me on this stuff as well. So we're talking about storage and data management, and one of the key changes that we've seen is that, as the question asked, we need to prepare this data, often at massive scale. And there's a key difference between HPC and AI. Using things like Spark, things like Trino, Dremio, massive big data frameworks to clean your data, sort the data out. And the cool thing is, this is a big difference between old HPC storage and new intelligent data. No longer are we the place where you just put your bits and bytes and then you bring them back later on. That's not an intelligent platform. An intelligent platform is going to interact in a way that you haven't seen before with Spark, with Trino, with Dremio to make it much, much more efficient, much easier for you to use, cost reduce the whole data cleaning process and the trading process and the inference process. So as you mentioned at the start, stretching above the stack, creating an integrated infrastructure builds the efficiencies that allows you to cope with these new challenges of cleaning massive amounts of data and metadata.
Yeah, that makes sense. I think one more question that's an add-on really to the question that Mike asked, and Mike, thank you for your question, is just, since AI is so new to these enterprises, the people within the organization themselves don't have a lot of experience with AI in general. So how do they upskill, or reskill in their specific areas? The IT folks, for example, the operations folks. Are there resources out there that they can use to really at least start their journey? Because I've seen various companies, Nvidia, for example, offer certification programs. Some of the cloud vendors do as well. Is that where they can get started to really, just upskill their knowledge? Or, what are your thoughts there?
I have a very simple answer. Just ask ChatGPT. That's what I did when I started, and Nvidia has great resources. There's a Coursera, which is from Stanford. There's a great classes, but I would start with Nvidia training because they've seen everything and they're actually building it. But then also you can start with in a cloud environment, start playing, practicing. You gotta look at the Nvidia and build this small pipeline for yourself. Not everybody in the company, but people that want to learn and intend to build, just do it. Spend the time. Time is money, but you invest the time and do it. It's not. It may appear complex. The tools are there.
Yeah, well, I back the idea of especially for the infrastructure side and a bit beyond that, leveraging one of our cloud partners. I mean, we work with several specialist cloud partners like Lambda, like Vultr. There's a bunch of them around the world, and they provide specialist infrastructure set up, optimized for AI. A great head start. And even if you go to Google now, they're running DDN's managed Lustre platform, which allows you to then scale the GPU access as far as you want to go, just from a straightforward public cloud platform. So certainly that's part of the answer, is use a platform that's already set up, ready to go and optimized, and that takes that headache away.
Yeah, that will simplify your journey immensely, right? There's companies out there that want to help, right? They build business models around helping folks who do feel challenged or stuck with their AI journeys or their transition from HPC to AI. So certainly, if you're interested, you can go to our DDN website and look at our partners. There's a whole list of folks out there that are offering services for folks who seem to feel stuck. With that, we are out of time. I do want to thank James and Izhar for joining us today at this Ask the Experts session.